is on absolute value equations and inequalities. So we kind of previewed this last time. We did a little bit, Xavier, a little bit with this last time. So let's go ahead and try the problems. So it says the absolute value of a number is always the positive version of the number. So for example, if I have the absolute value of -3, it's going to be 3. And if I have the absolute value of 5, it's just 5. We don't change the sign, we just make it the positive version. So if you have an equation like absolute value of x minus 2 is equal to 3, what we're saying is that when we take the absolute value of whatever's inside, we get a positive 3 out. So that means that this part that's on the inside, x minus 2 could be equal to 3, or x minus 2 could be equal to -3. Because when we take the absolute value of it, that's how we're getting 3 out. So we have two equations, and we solve both of them. So almost every single absolute value problem will have two solutions. There's two cases where we'd only have one solution. One case where there's one solution, one case where there's no solution, I guess I should say. So if it's set equal to 0, that's when I get one answer, right? Yeah. What if it's set equal to like a negative number, like -7? Then that's no solution, right? So we would say no solution there. So I'm going to get x equals 5 here, and I get x equals, if I add 2, I get -1. So my two answers here are 5 and -1. And you can always check. If you go back and plug in 5, you get 5 minus 2 is 3. Absolute value of 3 is 3. -1 minus 2 is -3. Absolute value of -3 is 3, right? So we know we're good. All right, so it says rule number 1. We're always going to isolate the absolute value part. So if it says 3 minus 2 times the absolute value of x plus 5, I never distribute the -2n. A lot of people do that, especially in Algebra 1. They always try to distribute. It's not a parenthesis. Can't do that. We just have to get the absolute value part by itself. So Sarkeesh, you with me? So we're going to subtract 3. When I do that, I have -2 times the absolute value of x plus 5 equals -18. And I want to get that whole absolute value just by itself. It's just like if I had like -2 times something equals -18. What would I do next if I had -2w equals -18? I would divide by a -2, right? That's what I'm doing here. I want to get the absolute value part by itself, so I'm dividing by that -2. So when I do that, I get the absolute value of x plus 5 is equal to 9. I have now isolated. The absolute value part is all by itself on one side. Now, this is where you do the thing where we break it into the two equations. Okay, so we have the absolute value of x plus 5 is equal to 9. So that means that this inside part could be 9 or -9, right? So that's when we break it into the two equations. So we say x plus 5 could equal 9, or x plus 5 could equal -9. And we solve both of them. Yeah. So we get x equals 4, Colin, and I get x equals -14. Write these down. Okay, so that's rule number 1. We always have to isolate. Everybody got that down? Isolate the absolute value. Get it by itself. So rule number 2, once you've isolated, sometimes there's funny things that happen. Sometimes we get the absolute value equals a negative number. That can't happen. We can't have the absolute value of something equaling a negative number. It's not possible. Okay, AJ, Max? So we're going to subtract the 5 over to isolate it. So I get the absolute value of 3x minus 1 equals -3. So do I break it into the two pieces? No. If you break it into the two pieces, both of those answers will end up being incorrect. You can plug them back in, but when you take the absolute value, you're not going to get -3. So it's not possible. So we say no solution. So we like those because it's less work, right? We like when it's no solution. So always make sure, after you isolate, make sure it's equal to a positive number. All right, so let's try some problems. So we did this the other day. So just like if we had whiteboards out, you guys do the problems just like if we had whiteboards. Yeah, Cameron?
I think the first one's no solution.
Ah, the first one works.
Okay.
Yep, because you have the absolute value of all of that equals 15. Okay, so we break it into two pieces. So we say, well, that inside part could be either 15 or x minus 7 could be -15 because when I take this absolute value, I'm going to get 15 out. Sarkees, try it. And I solve both of them. So just like if we had the whiteboards out, do the problem along with me. So you should get two answers. You should get 22 and you should get -8. Did you guys both get 22? Or all of you get both of those answers, 22? you plug back in, you'll get those correct answers. Yes?
When you take the absolute value of x and -7.
Good question. So a lot of people think when you take the absolute value of x minus 7, you get x plus 7. It doesn't work that way, okay? So the whole thing is going to be positive, meaning all of it is equal to positive 15 once you take the absolute value of it. So think about if you plug in 22. 22 minus 7 is still a positive number, right? So when we take the absolute value, that's how we get 15. Okay, so it's the whole output. All right, so don't change the signs. So we're just isolating it. So this next one, I'm going to subtract 6, subtract 6. I get the absolute value of x minus 1 is equal to 10. That means that everything on the inside, this x minus 1, all of it together, when I take the absolute value, I should get positive 10. So x minus 1, all of it could equal 10, or all of it could equal negative 10. So we break it into the two pieces. So we say x minus 1 could equal 10, and x minus 1 could equal negative 10. So we never change the left side of the equation. We just change the 10 and negative 10. And we solve both. So I'm going to add 1 and add 1. So I get x equals 11. I add 1 and add 1, and I get x equals negative 9. So those are my two answers. Feeling pretty good about this? All right, we're going to add 7, add 7. So I get 2 times the absolute value of x plus 5 equals 22. What's my next step? Yep, divide by 2. Divide by 2. AJ, are you with me? Every time I look up, you're talking. So I get x plus 5, absolute value equals 11. Okay, this is now isolated. That was our first step, right? Done. Now we break it into the two pieces. So we say that x plus 5 could equal 11, or the x plus 5 could equal negative 11, right? So we end up with two answers. We get x equals 6, and we get x equals, when I subtract 5, negative 16. Done. All right, so let's do the next one. So I'm going to add 3 and add 3. So I get the absolute value of 3x minus 2 equals 8. Is it isolated? Yep, so we've isolated, so now we break it into the two pieces. So we say 3x minus 2 could equal 8, or 3x minus 2 could equal negative 8. And we solve both of them. Oops, that's a 3x. Getting a little messy. All right, so I'm going to add 2. So I get 3x equals 10. And I get x equals, if I divide by 3 and divide by 3, I'm going to leave it as 10 over 3. So you can leave it as an improper, just reduce. You know, if you had 20 over 6, we would reduce to 10 over 3, right? All right, so the next one, if I add 2, I get 3x equals negative 6. And I get x equals negative 2. Those are my two answers. So previously, so some of you guys are going to get this, some of you guys aren't. Previously, we had nice answers, nice integer answers. We didn't have fractions. Why did I have a fraction all of a sudden on this one? Did you see it? So why were these? These were all like x equals 22, x equals negative 8. What do you think, Max? Yeah, like because it said 3x. Does that make sense? He says there's a multiple in the x. Yeah, so sometimes you're going to have fraction answers, so don't let that weird you out when you get fractions, right, Caitlin? You guys are getting better with fractions. You guys are good. All right, so we're going to subtract 7. Subtract 7, so I get 5 times the absolute value of x plus 7 equals negative 5. I divide by 5, So I get the absolute value of x plus 7 equals negative 1. Break into the two pieces. Ah, good. Xavier caught me. We don't want to do that, right? Don't do more work than you have to. This one is a no solution, right? So when it's equal to a negative, we just write no solution. Are you kind of remembering this from the other day? I know it's been a long fall break between. All right. So those are the absolute value equations. Do we feel pretty good with equations? Yeah, so let's do the inequalities. Inequalities are always going to have a number line, and we're going to write in interval notation at the end, okay? So it says, now let's think about absolute value inequalities. So I showed you why this was true the other day. So if I have the absolute value of x is less than 5, and I think about a number line, I should have made it bigger. Remember how we did this the other day? We went through and we said, okay, this number works, this number works, this number works. You guys remember that? I'm running out of room. I should have done something smaller than 5. All right, so if I do the number line and I think about numbers that I can plug in, does 0 make this true? If I plug in 0, absolute value of 0 is 0. Is 0 less than or equal to 5? Yeah, it works, right? What about 1? Absolute value of 1 is 1. 1 is less than 5. 2 works. 3 works. 4 works. 5 doesn't work, right? Because 5 is not less than 5. Okay, so it doesn't work. What about 6? No. Negative 1? Yeah. Negative 2, negative 3, negative 4. Negative 5? No. What about negative 4.5? Negative 4.5 works. So everything up to negative 5, so everything between negative 5 and 5 works. So that's what it would end up looking like. Okay. So the way that we break this apart is we think about 2 inequalities. So the first one is that x has to be less than 5, right? Do you guys see how we have all the values that are less than 5? Except x also has to be greater than what? Negative 5. So what we say is and x is greater than negative 5. And it's where the two things overlap. Okay? So we have x is less than 5. Do you notice how that's exactly the same as just dropping absolute values? X is less than 5. What about the other one? We did x is greater than negative 5. So I flipped my sign, my inequality sign, and I made it negative. All right, so what if I have x is greater than or equal to 2? So we can kind of go through the same process. And negative 4 and 4 and so on. So does 0 work this time? No. Is 0 greater than or equal to 2? No. So it doesn't work. 1 doesn't work. 2 doesn't work. Wait, does 2 work? 2 does work, right? So 2 works, 3 works, 4 works, 2.1 works. So the way that this one would be set up is like this. So an open circle there, and then over. And what's the first thing on the left that we hit? Negative 2, right? And then everything over. So these ones worked as well. But negative 1 did not work. Do you guys understand what I'm saying? Like we plugged into the original. Okay, we're not always going to do it this way. There has to be a pattern. Okay, so this means that x is greater than or equal to 2, or x could be less than or equal to negative 2. This is an or statement. Okay, so do you guys remember when we talked about inequalities? And means they overlap, and we shade where they overlap, or means that they could go in opposite directions. Do you guys see how this one goes in opposite directions? This is norm. Okay, so it says if you isolate the absolute value and you have less than or equal to, your shading will go towards each other, and they'll overlap. So when you have something pointing in, this is like an arrow that is pointing in towards the absolute value, right? So when you have a less than, it points in. They end up pointing in towards each other. So see my fingers pointing in towards each other. Okay? But if they go away, so if you have an absolute value and it goes away, then they end up going away from each other. Okay? So I used to tutor a girl and she said, oh, my teacher always said, go LA. And I like that. So greater than means or, less than means and. Can you remember that? Greater is or. And less than is and. So go LA. Okay, so let's try some problems. So I have the steps there, but we'll go ahead and do the examples and you'll see. So it says, yeah, and is and, or A is and. Less than is and. All right, so if the absolute value of x minus 4 is greater than 3, so same steps as before, we still have to isolate. Is it isolated? Yeah, so we're good. So we're going to break it into the two. So we're going to say x minus 4 is greater than 3, and we're going to say x minus 4 is less than negative 3. Notice how I flip the sign and I make my number negative. Did I change anything with the x minus 4? No, I just dropped the absolute value on each of those. Does that make sense? So I had greater than 3 just like before, and I do less than negative 3. Would this be an and or an or? And. No. Or. What is it? Greater, G-O, go L-A. Greater than means or. So we're going to put an or in between. I always said when I first started teaching, I said if it points away, they point away from each other. It's an or. Okay, so I'm going to get x is greater than 7, and I'm going to have x is less than, if I add 4, less than 1. So if I put both of those numbers on a number line in the order that they are in, the 1 first and then the 7, I have everything that's less than 1 and everything that is greater than 7. So I have two pieces, the left piece or the right piece. So the last step is to write it in interval notation. Do you guys remember interval notation? Read it like a book, left to right. I have negative infinity to 1, parenthesis, union, 7 to infinity. Good? All right, what do I have to do first on the next one? It's different than the first one. It's not isolated, right? We've got to isolate. So if I'm isolating, I'm going to add 3. So I get 2 times the absolute value of x minus 7 is less than or equal to 10. Divide by 2, divide by 2. I get the absolute value of x minus 1 is less than or equal to 5. So we isolated, right? So we're good. So now here's where we break it into the two pieces. So the first one's going to be exactly the same, no absolute value. So we're going to have x minus 1 is less than or equal to 5. And the next one's going to be the same except we flip the sign and make the thing negative, right? So I'm going to have x minus 1 is greater than or equal to negative 5. Sarkis, try these problems, please. You guys are not doing very hot on your homework. The homework has not been good lately. So try the problems in class. You guys know how to do them. All right, add 1, we get x is less than or equal to 6. Add 1, we get x is greater than or equal to negative 4. Is this an and or an or? It was pointed in towards it. Less than means go LA. And. So we're going to put an and between it. So we basically need for both of those things to be true. So usually when this happens, they're going to overlap. There are some weird ones, but I think in Algebra 1, they're mostly pretty straightforward. So we have greater than or equal to negative 4 and less than or equal to 6. So less than or equal to 6 would go this way. Greater than or equal to negative 4 would go this way. So do you guys see it's where they overlap in the middle? Whoops, lost all my numbers. So we're going to do filled in on each of them and then shading between. So my answer, who can tell me how to write this in interval notation? Cameron, do you remember?
Is it bracket?
It's a bracket, yep. Negative 4.
4, 6 bracket.
You got it. That's it. All right, I want you guys to try the last two on your own. So try the last two on your own. I'll pause. All right, here we go. So I'll do it up here. So check your work. Make sure you had the same thing. So we're going to add the 4 to both sides. Did we all add 4? So you should have 3 times the absolute value of 2x minus 1 is greater than or equal to 15. We divide by the 3. So we get the absolute value of 2x minus 1 is greater than or equal to 5. So when we break into the two pieces, the first one's going to be exactly the same, just no absolute value. AJ? So we're going to have 2x minus 1 is greater than or equal to 5. And the next one is going to be 2x minus 1 is less than or equal to negative 5. Okay, we add 1. I get 2x is greater than or equal to 6. I get x is greater than or equal to 3. I add 1. I get 2x is less than or equal to negative 4. I get x is less than or equal to negative 2. Would I put an and or an or in between it? It's a greater than originally, so it's an or, yep. So when I graph it onto my number line, I have my negative 2 first and then my 3 next. I have everything that's less than or equal to negative 2 and everything that's greater than or equal to 3. They point away from each other like I expected because it was an or. So my answer is going to be negative infinity to negative 2, bracket, union, bracket, 3 to infinity. Like that. Colin, stop. When it's a filled-in circle, use bracket. When it's open, use a parentheses. So the filled-in means that it's equal to. All right, so this next one, tricky. Subtract 5, subtract 5. I get the absolute value of x minus 3 is less than negative 2. What do you guys think? It is no solution. Do you guys all see why it's no solution? You have an absolute value, which is always positive, is smaller than negative 2. It can't happen. It would be no solution. Okay, other quick question. So what if it said absolute value of x minus 3 is greater than negative 2? Could you plug in anything for x and get it to work? What if I plugged in 0? Yeah, 3 is greater than negative 2. Could I plug in anything? You can. You can plug in any number for x. Because think about it. When you plug in any number, doesn't matter what it is, it can be negative 1 billion. Minus 3 is negative 1 billion and 3. But when I take the absolute value, it's positive 1 billion and 3, which is always greater than negative 2. So what do you think we would write for an answer? Would we write no solution? No. Anything works, right? So what do I write? That would be all real numbers. Or you could say infinitely many solutions if you want to, but all real numbers, right? It doesn't matter what you plug in, it would always be true. So there can be tricky ones. If I said greater than or equal to, that would still be all real numbers, like greater than or equal to 0, I guess. What if I said greater than 0? So what if I said absolute value of x is greater than 0? Would every single number that you plug in work?
No.
Except for what? 0 does not work. Negatives would still work, but 0 would not work because I said greater than or equal to. Okay, so it's tricky, so you kind of have to think about weird ones like that. All right. Let me give you your homework.